Let me try this way. Huh? Where's the ball? Where did it go? Huh? Yo, man, did you see what happened there? The ball disappeared. What? What are you talking about? It didn't disappear. Let me show you what happened. There it is. The ball's in the closet. It didn't disappear. So, you're saying that the ball went through the closet door? Are you kidding me? How's that even possible? How's this even possible? Yes, it is possible. But since you don't understand about quantum physics, I will give you a quick lesson about quantum mechanics. First, talking about quantum, the two most common terms are quantum mechanics and quantum physics. Quantum mechanics focus more on math, while quantum physics focus more on theory. And today, I will focus more on quantum mechanics, but just the theory part of it. Two major things that I will talk about today is superposition and quantum tunneling. Now, imagine you have a group of Americans and you want to divide them into different groups with people that have common things. You decide to send them into a room where the judge, I will call them J. These judge's job is to detect whether the person's skin is black or white. For example, if I send Taylor Swift into the box, the judge will say that she's white. I want to divide them into different groups depends on their skin. But my friend, on the other hand, want to divide them based on their physics. So he will send them into a room that have a coach who will divide them into strong and weak people. So let's say I have Taylor Swift. I send her into a judge room and the judge say that she's white. And then I send her into another judge room. What do you think the judge is going to say? Yes, the answer is white. Because the answer will never change. If the first judge says that she's white, then the second judge has to say that she's white. Now, here comes the tricky part. We have LeBron James. We send him into a room of a judge. The judge will have 50% saying that LeBron James is white and 50% saying that he's black. Let's just say the first judge say that he's black. Then we send him into another room. But this time, it's not the judge, it's the coach. And the coach will have 50% saying that he's weak and 50% saying that he's strong. And let's just say the coach say that he's strong. So he comes out of the room as a strong person. But here is the trickiest part of this experiment. We send him back into the second judge's room. What do you think the judge is going to say? The common thinking here is that 100% chance that LeBron will come out to be black, because based on the last experiment, we know that if we send a person into a box and they come out to be a white person, we send them into that box again, they will come out to be a white person 100% of the time. But this is wrong, because the answer is that 50% chance that LeBron will come out to be white and 50% chance that he will come out to be black. How is it even possible? But this is exactly how electrons and particles behave. Now, here comes another experiment. We have this model. We have a group of people. We send them first into the coach room. Then they will have two paths to go, depends on which path the coach sent them to. So we have a strong path and a weak path. And after they come out of each path, they will bounce off a wall and meet up again in a blank room. Oh, and by the way, this room will never change in this model. And then all of them will be sent into either a judge or a coach room one more time. So for the first experiment, we will send a group of white people through a coach room. So first, when we send them into the first coach room, 50% of those people will go the strong path and 50% go the weak path. After they go their way, they will meet up and then all of them will go to the last coach room. After doing this experiment, we see that the number of people comes out to be strong is 50% and 50% comes out to be weak. For the second experiment, we will send in a group of strong people, and so when they comes in the first room, which is the coach room, 100% of them will come out on the strong path and 0% of them will come out on the weak path. That is what we have from the first experiment. And so all of them will meet up in the blank room and all of them will go into the judge room. And so we know that 50% of them will comes out to be black and 50% will comes out to be white. So let's move on to the third experiment, where we send in a group of white people and the last room is the judge room. So the first thing happened is that the group of white people will go into the coach room and then 50% of them will come out on the weak path and 50% of them will come out on the strong path. Then they will bounce off the wall and meet up in the blank room. Then all of them will go into the last judge room. The question is, what is the percentage of black and white people we will have? Just take a minute or two, stop the video and think about it, because the answer will blow your mind. The common thinking is that 50% of them will come out to be white and 50% will come out to be black, because as we know from the previous experiment, if we send a white person in a coach room, there are 50% chance that he will come out to be strong and 50% chance to be weak. Then doesn't matter which way he go, we send him into another judge room again, then he will have 50% chance come out to be white and 50% chance come out to be black. But once again, quantum physics is not normal. The answer is not 50-50 because 100% of them will come out to be white. Are you kidding me? How's that even possible? So now let's move on to the last experiment, the fourth experiment. In this experiment, we will still send in a group of white people and the last room is the judge room. However, the difference is now we have a barrier in the strong path. So that means everybody that goes the strong path will be blocked and so they can't continue to the blank room. So what still happen is that 50% of them will go the weak path and 50% of them will go the strong path. However, everyone who goes the strong path is blocked, so only 50% of the people in total will come in the blank room, and then they will go into the judge room. So the question is, what is the percentage of black and white people will we have? We already know that 50% of them are blocked, so 50% of the people in total will be lost. For example, if we send 100 people in, only 50 people will come out. So even though the third experiment we just did said that 100% of them will come out to be white, and the only difference this time is that since we have a barrier, the number of white people at the end will be half. Or we can say that we have 50% people get lost, 50% people are white, and 0% of people are black. But the truth is, 25% of the total people will come out to be black, and 25% of total people will come out to be white. Okay, how is it even possible? Maybe things just seems to be messed up in the quantum world. So it seems like we have done something wrong in the third experiment to give us 100% people coming out to be white. That's why we have to find that which path did they go into to end up 100% of them being white. So my first thought is that they went the weak path. So in order to confirm it, we just need to block the strong path. And that's exactly what we did in the first experiment. We end up with 50-50. So nope, it's not the weak path. And so same thing with the strong path. We block the weak path and it's the same experiment again. So nope, it's not the strong path. Then how about they split in half and went both way? So in order to confirm that, we send only one person into the system and we observe. Luckily, we didn't see any half of the person in any path during this experiment, which means they're safe. But surprisingly, we only see one person in either weak path or strong path. We never see half of a body in any path. We only see one body in one path. So that means they didn't go both paths. How about they didn't take any path? If they take none of them, then the answer would be 0%, and so it's no, of course. So then what happened here? Which path did they go that make us end up with 100% to be white in the third experiment? We tried to prove every possible situation that we can think of. Weak, strong, both, none. But none of them can explain what happened in the third experiment. The explanation from scientists who did this experiment is that they were in the state of superposition. The easiest way to imagine this is that we have a person, and that person is a superhero, and he can duplicate himself into two. One version of him will go the strong path, and one version of him will go the weak path. And that is how electrons behave. What I was talking about is an actual experiment that was done by scientists. They use electron and they have device to detect them. They send electron into that device. The device will tell them that whether the color of the electron is white or black, and the hardness of the electron is soft or hard. Instead of using electron, which is a tricky thing to talk about, I use human, which is closer and easier to be related to us so that we can understand it easier. So technically, the electrons that scientists use in the actual experiment is human in my experiment. And so the conclusion of this experiment is that an electron can exist in two states at a time, and they're called superposition. So I've just taught you about superposition. Now let's move on to quantum tunneling. In quantum tunneling, there's a concept called the wave-particle duality, and the easiest way to explain it is by using the double-slit experiment. In double-slit experiment, we know that light can exist in two states at a time, which are wave and particle. And scientists were shocked at that time when they were first doing this. But we have a evidence that support that. But we had evidence to support that particles like electrons or photon can exist in two states at a time. In normal world, particle can be located in 3D using XYZ coordinate. However, in the quantum world, which deal with elementary particle, the location of these particles can be described in terms of a probability wave. This wave indicates the point where the electrons is most likely to be found and the least likely to be found. And so, this is the graph of the probability wave. So, according to probability wave, we know that if I throw this ball into this box, the location of this ball after it touches the box is bounce off, because that's what's most likely to happen. It's like the highest point of the graph I just showed you. There's still a teeny tiny small chance that it will go through the box, because that way is least likely to appear after it touches the box, but still there's not a 0% chance. It's close to zero but not zero. So that's why this is what usually happen, but still this is possible. So I've just gave you a quick lesson about quantum mechanics, and we discovered that a particle can exist in two states at a time, and because of the probability wave, there's a super small chance that an object can go through wall. Even though it's small, it's not zero, so it's still possible. Did you understand what I've just taught you there? It's that, bro. That's nonsense. You just bad at your experiment. What are you saying, bro? I'm sorry, I'm so sorry, I'm sorry. Oh, don't hit me, don't hit me, don't hit me. Hi, wake up. You're doing trick shot, right? Where's my ball? Where did it go? Did you lost my ball? Huh? What are you talking about? Ball? What ball? Are you talking about? No way! So let mercy